So let's go through our practice problems now. Um, so first off, this one says an object traveling at 150 kilometers an hour slows to 10 kilometers an hour in 5 seconds. What is the acceleration? So let's write down what we know. We know VI, the initial velocity, or V1 you might see too. So VI is 150, right? That's what you started at. So 150 kilometers an hour. VF, the final velocity, is going to be 10 kilometers an hour. And the time is 5 seconds. And then we're looking for the acceleration. So I'll put a question mark there. Then we write down our formula. So the formula is A is equal to VF minus VI over T. Or that might say V2 minus V1. Doesn't matter, right? Okay, now let's fill in. Really, we just got to plug in the numbers here. So we're going to go, I'm just going to write this over here because of lack of space here. I'm just going to write A is equal to VF was 10 kilometers an hour minus VI was 150 kilometers an hour divided by a time of 5 seconds. And normally I'd say, I forgot that little dash there. Normally I'd say you wouldn't want to have it in kilometers per hour per second. But like I was saying before, it didn't actually tell us what to have it in. So let's just keep it in kilometers an hour per second. That is still acceleration. So if we do that, you find that A is equal to. But actually, before I tell you the answer, I want you to kind of see what I did wrong here. So this is my calculator, and I went 10 minus 150 divided by 5. And if I push enter, the calculator even kind of showed me what it thought I meant. It thought I meant 10 minus 150 divided by 5, right? So order of operations matter here. So if you're going to put all the numbers in your calculator, I got minus 20 for an answer. And you can see that the answer is actually negative 28. So the way I want you guys to do this, if you're going to put it into your calculator all in one swoop, use brackets, right? So you're going to have brackets. Everything up top, you're just really, this is what you want. You want 10 minus 150, all one thing divided by 5. So put it in your calculator like that, these kind of imaginary brackets that are there. So you go 10 minus 150 and then divided by 5. And now you can see, now it knows what I meant, right? So the answer is actually negative 28. So negative 28 kilometers per hour per second. Okay, the next one I'm actually just gonna, I'll put the answer down and then I'll just, or I'll pause it, and I'll put the answer down for you. So go ahead and give it a try on your own though. So pause the video now. All right, so for number 2, it says an object accelerates from rest. That's telling you info, right? From rest, that's 0. At 4 meters per second squared. As soon as you see that meters per second squared, that's the acceleration for 1 minute. What is the object's final velocity? So I wrote down my info down here. I changed minutes into seconds because this is in meters per second squared. So my time had to be in seconds to make that all work, right? And then I wrote down my formula. I rearranged the formula to solve for VF. And then I got VF is equal to 240 meters per second in positive direction. All right, next one says, how long would it take for an object traveling at 60 meters per second to reach a speed of 100 meters per second if the acceleration is 5 meters per second squared? So we're looking for T. Okay, so go ahead and give this one a try again. So go ahead and pause it now. Okay, there's your answer there. Just notice too that if I would have got a negative answer for my time, that'd probably be a big hint that you got these two numbers backwards. You got your VF or your VI mixed up. Okay. Number 4, a rock is thrown upward with an initial speed of 12 meters per second. How long will it take for the object to get to its maximum height? What's the rock's velocity after 1.5 seconds? All right. I'm actually going to do this one over here a bit, maybe, so we zoom out. Just so we have a bit more room. So it says a rock thrown upward with an initial velocity of 12 meters per second. So I'm going to go VI is equal to 12 meters per second. And it's going to be positive, right? Because it's going up. Remember kind of conventions here. Up is positive, right's positive, down's negative, left's negative. So this is going up, so it's going to be positive 12 meters per second. It says how long will it take? So I'm looking for T, but here, let's do VF first. Keep it the same as the way we've been doing it. So VF, though, remember, if you throw something up in the air, it has to come to a stop before it comes back down again. So at that point right there, VF is going to be equal to 0. We needed that, right? The acceleration now. It seems like we don't really have an acceleration, but we always do when you throw something up in the air. Everything on Earth accelerates downward at negative. It has to be negative because it's down, or it's toward the Earth. Negative 9.81 meters per second squared. And then it says how long will it take? So T with a little question mark. Okay, so now let's rearrange this. I'm just going to write the formula from here and say T is equal to VF minus VI over A. I just rearranged it already. And now T is equal to, VF was 0. VI is 12 meters per second divided by negative 9.81 meters per second squared. And now you can see I've got negative 12 divided by negative 9.81. That's perfect because negative divided by negative is a positive. I'm really expecting that I'm going to get a positive time out of this. And my answer is going to be 1.2 seconds. This actually on your sheet says 1.22. That's actually not right. It should be 1.2 because 1.5 is our lowest sig digs. We should have the same number of sig digs for our answer. Okay, now for part 2, it says, what's the rock's velocity after 1.5 seconds? We can really do all the same stuff, so this will be part 2 over here. We still know that VI is 12. We know, but now VF is not going to be 0. So here, I'll write down what we know. All right, there you go. So now we've just kind of changed up a bit. Now this time we know the time. We don't know VF. So all we got to do is rearrange for VF. So let's say A is equal to VF minus VI over T. And then rearranging, we've got T times A is equal to VF minus VI. And then finally, T times A plus VI is equal to VF. And then just fill in what we know. So we got 1.5 seconds times negative 9.81 meters per second squared, plus our initial velocity was 12 meters per second. And that's going to be equal to, we'll say VF there, and then equals negative 2.7 is what VF is. Now remember what that negative means. Negative 2.7, that just means down, right? So it's on its way back down again. So we've got this thing goes up and goes back down again. And this kind of makes sense because it took 1.2 seconds to get to the top. We're talking about like how fast is it going at, what was it, 1.5 seconds? So that makes sense. It's on its journey back down again. So that's where the negative comes from. All right, moving on to the next one. Number 5, last one. All right, so number 5 says a ball traveling at 10 meters per second begins rolling up an incline. It comes to a stop 5 seconds later and begins to roll back down. So part A says, what is the acceleration? So this ball goes rolling up. It comes to a stop right here. So we know a bit of things, right? I find it might be easier to draw where we know stuff on this picture. So I'd say VI is equal to 10 meters per second. VF, remember, it comes to a stop. VF is going to be equal to 0, so that's helpful. And we know it comes to a stop 5 seconds later. So I guess up here too, you could say time is equal to 5 seconds. So we know 3 things. We can now find the last one, right? So let's write down our formula. We got A is equal to VF minus VI over T. And now it just says, what is the acceleration? So we just have to plug stuff in here, really. And just so you're aware, we can call anything we want positive and negative, right? We can make whatever conventions we want. We are going to call up the ramp positive. So this way, maybe I'll write it down here. Up the ramp, we're going to consider to be positive. And down the ramp, we're going to be considered negative. So, yeah. So keeping on going with this, we're going to say A is equal to VF was 0. So 0 minus 10 divided by 5. And they end up with A is equal to negative 2 meters per second squared. So negative 2 meters per second squared. You could also say 2 meters per second down the incline, right? Because that's really what's happening. That's what that negative means. Okay, so that was part A. Part B, let's do, I guess, over here. Sorry about that. Let's do B. Now, the key bit here is it says, what's the velocity after 2 seconds? I know the acceleration, right? As soon as I found the acceleration for any point on this ramp, remember, the acceleration is the same at every point. Even though it like comes to a stop and then speeds back up again, you have one number for the acceleration of this thing. That one number is negative 2. All right, so we can now use that negative 2 for part B. So let's write down what we got. So VI is going to be equal to 10 meters per second. VF is what we're looking for. Time, well, actually, acceleration, let's put down negative 2 meters per second squared. And time, it says 2 seconds. Okay, now we just need to solve for VF. I'm just going to put down the formula, the rearranged formula already. So that is VF is equal to A times T plus VI. So make sure you can rearrange to get there. Now VF is equal to negative 2 meters per second squared times 2 seconds plus 10 meters per second. So VF is equal to 6 meters per second. And 6 meters per second up the incline. Which again kind of makes sense, right? Because it takes 5 seconds to get to the top. So this thing is still on its journey up the ramp at that point. All right, last one, C. What's the velocity after 7 seconds? Everything here is going to be the same. We just got to do it for a new time. So I'm just going to write down what we know again. So C. Got VI. Here, I'll just put them all down. All right, so if you do that, just pretty much the same as last one. The only difference is that the time here is 7 seconds instead. You get negative 4 meters per second. And the negative, remember, just means down the incline. All right, so that's it for the practice problems. I'd like you guys to go ahead and do the hand-in assignment. Remember, do them on a separate sheet of paper. And actually, all questions for this one. There's no stars beside any of the numbers, so they're not the hard ones. Okay, so that's it for that one, and I'll see you in the next video.